In this video tutorial, I want to talk about the fillet edge tool, which you can also fillet a polysurface, which you can see here. I can change the fillet on a polysurface, and then I'm going to explain how you can have the curved surface in one output and the flat surfaces in another output. So you can find the fillet edge tool in the surface and the utility section, or you can simply search for fillet edge by here. Okay, so let's just get started from the scratch. I'm going to go to the params menu and go to the point. Let's just put the bifocus plugin here, and let's produce multiple points here. So I'm going to produce multiple points to make a polyline, and let's go to the curve and use the polyline tool to produce a polyline. So here we go, give the vertices to this, and for the closed section we can simply put a toggle, boolean toggle, and set it to true, so it's just getting closed. Okay, so by changing these points coordinates you can change the polyline and produce a polyline. Okay, so then I'm going to go to the params menu and use a surface to produce a surface, and then extrude that EX in the Z direction. This is the fastest way you can produce a solid and a polysurface. So I can show you how you can fillet a surface on that polysurface. So now we can simply produce a polysurface by changing this points and producing different results. Okay, so what I want to do is to go to the fillet edge in the surface and in the utility, and this only works on Rhino 6. So if you have Rhino 5, you have to upgrade to Rhino 6, and now I'm going to go and give the extrusion to the shape. You can see that this will use a polysurface, so the input is basically a B-rep or a boundary representation. Okay, the next input, so just turn this off, is blend, and you can see that is the fillet blend type. If you right click on this, you can see that there are three inputs: fillet, chamfer, and blend, and you can choose one of those by going for two ways. The first way is to simply give a 0 to 2 number sliders. So 0 is going to be blend. If I just put this, 0 is going to be fillet, and 1 is going to go to chamfer, and 2 is going to go to blend. And another way is to go to this params menu and use this value list in here, and let's just double click here on the 1, and now you can type here. So it's going to be fillet equals to 0. Okay, let's just correct this. Chamfer equals to 1, and blend equals to 2. And by typing on this, you can see that I can choose between these different options by just click on here. Okay, and you can just change this to and delete the value list, so it's just a single value list, and the name is here. Okay, you can right click and have this as a checklist, and you can change it whenever you want. And remember, if you just choose all of them, will have 3 fillet edges, so be careful about that. And you can also go to value sequence when you can just change this, or the best is the value cycle, which you can just go between different results. Okay, I'm going to go to fillet. The metric is you can see the rolling ball, edge distance, and rail distance, and you can study about these in Rhino. But for the rolling ball, if you have an edge fillet, so assume that we have to fillet this edge, a ball will be just rolling on this surface and produce that fillet. So this will be the fillets. That's a rolling ball. The edge distance will be the distance between the edges you are filleting will be the same as you just defined. We will define it here. And the rail distance is the distance between rails. So the edge and the rail are something similar. So let's just do this. And I'm going to put that between 0 and 2, and then check the results. I'm going to put that between 0 and 2, and then change that later. Okay, so the edges we want to fillet that, you have to give the index to that edge as a list. So what are the numbers of that edge? If I just go to the surface and use this deconstruct brep, we will have the faces, edges, and vertices. And now we can just go to the curve and use this point on curve to show a point on the middle of the edge. And why I'm doing this is to show the number of the edge. We can go to display and use this point list, give this point here and just turn this off. And let's just give this a size. And you can see the number here. So let's just bake this so it's better to see the numbers, okay? And you can see those numbers are the edges you want to produce the fillet. So if I want the top, perhaps it's going to be 2, 4, 7, 10, 13, 16, 19, 22, and 25. So if I want to do that, that's going to be a little bit hard. So if I just go here, let's just put this a little bit here and go to the edges, set multiple integers and type this. So it's going to be 13, 16, 19, 22, 25, 2, 4, 7, and 10. Okay, and then give this a radi. So let's just do this. And perhaps we have to change this number to get the results. You can see that I am filleting all of the top edges I want. So we can change that and maybe just decrease the Z direction extrusion. So we'll just have simple fillet. And you can see that you can't just increase that because there's a place that those fillet will fail. So remember, you have to play with those numbers. Maybe we just give this a little bit of extrusion. And I guess that's not too much. You can see that I can just increase that, and let's just see the result. And here it is in the shaded mode. You can see the results. So this is the way you can just fillet those numbers. But the best way you can do this, I'm going to explain another way, and that is how can I and just say that I want to maybe fillet this face. So we're going to switch on faces. We can do this by deconstructing the extrusion, okay? And here we have the faces, and use the list item to choose between the faces. So let's just go between, there are 11 faces here, you can see here. So it's perhaps starting from 0 to 10. Okay, let's just go back. That's 10. So I'm going to give a number slider between 0 and 10. And this will be the first face, and so on. With this number slider, I can just pick between those faces. So let's just go to the top and assume that we want to choose between on the top. So I want an algorithm to extract those edge numbers without me typing them here. How can I do this? Okay, let's just go and again explode those edges, those faces, that face we just picked. And again, pick the middle of this edge. And let's just go. And this is a technique you can use. Again, connect a mid edge on the edge of all of those edges we have. So these are two set of points I have. And why I just use this is because you have to focus on points and not on geometry like curve and surfaces. If I have a group of points and I want to know the number or the member index, the index of these vertices or the points, you can search for member index, or go to the sets section, and here we have the member index. This can help you extract the member index of the top, and remember this was the exact number we need to have. So how can we reach those numbers? By the member index, the set is the all of the points we have, so we give this the set, and the member is the points we want to check out, okay? So if I give this to the index, you can see that this is producing a set of points: 2, 4, 7, 10, 2, 4, 7, 10, 13, 16, 13, 16, 19, 22, and 25. So this is exactly the indexes we want to extract, and we can simply flatten this because these are in groups and have them in one group and give this output to the edges. This way we can simply, okay, let's just turn everything off. We can simply just change the fillet edge. Okay, I have to decrease that because we have a big number for the fillet and the face is not a good one, but you can see here. Okay, let's just turn this off, and you can see that I have used this to fillet edge this part. Okay, we can just switch on this one and perhaps this one, and the 10 is on the top and 0 is on the bottom. So you can see that we can do that because of the groups. If I give this a 0 and a 10, you can see that we can also have fillet edge on the top and the bottom. So let's just do this and produce the results. You can see that you can just reach a point they intersect, so that's perhaps going to give us an error. So just be careful about this and put that on your model. Okay, so now I can just have this result here by that. So what I want to do is to, you can see there's a flat thing here. Let's just go back to maybe 1, and that's on the top of that. Okay, and increase that. You can also use this for architectural project, and how you can do this is to simply define a building. Assume that this is a building. I'm just going to move these things. This is a building, and you want to make an entrance, and this is the roof, and this is a fillet wall. So you can also use that technique to produce architectural project if you want. So now, for those who want to have the curved surfaces so they can panel that for the future, they can use this technique. I'm going to explode that fillet polysurface into faces, and now we need those curved ones. Maybe we just need those curved ones and we don't need those other surfaces. So we can do this by going to the surface, you analyzes, and searching for is planar. Okay, or just search for planar, and here it is planar. That's the command. You can just check this surface if it's flat or not. So we know these surfaces are flat, but this is not. So you can see that the planar, some are true, some are false. So simply, this will just give you the opportunity to use the dispatch. You can also watch the dispatch tutorial to understand about it. So I'm going to dispatch the faces based on the true or false we gave it here. So let's just turn everything off, and we have two set of groups: those who are flat, which is the roof, the walls, and the floor, and those who are not flat. And you can see how simple it is to extract that. And you can also change that fillet to chamfer, but remember, if you just put that as a chamfer, this will be just flat, so you can't use this technique. To do that, you have to go for another way. That's perhaps going for the direction of the vectors. So then you can also go for blend, and you can see that this is giving you 2 or 3 different results. The next one is the metric, so I'm going to change the rolling ball into edge. 1 doesn't really change that, but the 2, the distance here, is controlled with this number. So this is a way you can just use that to have a standard distance and a fixed distance between those edges if you want to. And remember, always you can have different faces with the shift key. Let's just give this to the 0 and produce, if you are going to produce something for industrial users, you can also use this technique to have it as the fillet edge tool. Here we go. You can see that this is really great for those who want to design something and use that maybe for something in industrial purposes. Okay, so I can now just change those points and produce different results. And that was the way you can use that. You can also use that fillet edge for many other ways or other polysurfaces you can. So thank you for watching, and comment on this video. Your opinion and your comments and likes really help us, help our channel to grow, and so we can make more videos. And thank you for subscribing to our channel.
Thank you for watching and subscribe to our channel. And you can also watch something that is related to this video, that corner, and see you next time.